Within this session, as I mentioned, we're going to be looking at controlling our simulation using a spreadsheet. We're also going to take a look at adding some staff into the simulation as well. And then finally, we'll take a look at linking our model to Excel. For those of you who missed the first two sessions, session one was taking a look at the basic objects within simulation and just getting started in using the software. In session two, we added some additional complexity where we set up different colors of cars within our car manufacturing plant. We also have session four, which is going to be coming up in a couple of weeks. We'll give you a little bit more detail at the end of this webinar. And within session four, we're going to be taking a look at using a feature called Visual Logic to create some custom reports. Before we get started on the new features that we're going to take a look at today, I'm just going to give you a quick recap from webinar 2. So in webinar 2, we built the in webinar 1, we built the basic structure of our simulation. And through some experimentation, we decided that we wanted to add the second assembly line here. We justified the cost based on the throughput of our cars. In the second webinar, we added some additional complexity, which was having different cars moving through the system. That basically means that, for example, at the paint activity, we can look at setting up changeovers so that we clean the spray painting gun before a different color of car is spray painted. We also used labels to route out from the shipping activity to different areas of the simulation. So labels are a very useful feature within Simulate, and they can allow us to store a whole host of information about our work item. Moving back to the slides, we're going to take a look at a feature which we call resources. And resources are used whenever something is in limited supply. So for example, resources can be beds in a hospital. They might be people answering the phone in a contact center. They could be, as in our example, machine operators in a factory. But really there are hundreds of different types of resources. We're going to take a look at a couple of examples in our simulation. The first one is going to be assigning a resource directly to an activity, which basically means that the activity requires a machine operator, in our example, in order to process work. We're also going to take a look at how we can set up our resources so that we choose either one resource or another at an activity. There's many other resource options available within Simulate. Unfortunately, we don't have time to go into them all today, but there will be some time at the end of the webinar for you to ask some questions. So hopefully I can cover some of your questions during that time. So I'm going to jump into the software, and we're going to take a look at actually adding some of our resources. The resources are found on the left-hand side of the Simulate interface here, and you can see I've got this little resource button. When I click on resource, we get a little crosshair, and I can simply click on the screen to add that resource. Now, when I'm working in a workshop environment with my client, I'd be asking my client what type of resources we have within the factory. They might tell me that they have assemblers. So I'm just going to click on the resource and change its name to assemblers. You can see here that I have a number available, which by default is 10. I'm going to change that so that we've got 2 assemblers available. I'm going to add a second resource, and that second resource is going to be some painters. So I'm going to select the second resource and change this to painters. And this time I'm going to say that we have 3 available. At the moment, if I was to run my simulation, we wouldn't use any of these resources. And that's because we've not told Simulate which activity requires which resources in order to be able to run. So I'm going to assign my assemblers, first of all, to the bodywork activity. When we're assigning resources, I want to hold down my Shift key, and then I want to click and hold my mouse on the assemblers resource. When I do that, you can see that the cursor turns to a question mark. I can then, keeping my mouse held down and my Shift key held down, I can hover over bodywork. When I do that, you can see that it turns to a thick black arrow. That means I can release my mouse and we get a little message popping up telling us that the assembler has been assigned to the bodywork activity. If I click on assemblers now, you can see a little pink circle showing that that resource has been assigned to that activity. I'm going to repeat that process for the assembly 1 and assembly 2 activities. And for the painters, I'm going to assign them to the painting activity and also the sanding activity. Again, if I click on the assembler resource, you can see all of the different activities where it's assigned, and likewise for painters. So this is an example of us applying a resource directly to the activity. Whenever a work item arrives in this queue here before bodywork, we need to have an assembler available in order to perform the bodywork activity. If there's no assembler available, the work will remain in the queue before the activity. I'm also going to add another resource type, and that is going to allow us to choose either an assembler or a painter at either one of my inspection activities. To do that, we set up what's called a pooled resource. To set up a pooled resource, I simply click on the resource and add another resource, just in the same way as we did previously. I'm going to change this resource's name to, let's say, a pooled resource, but equally we might want to call this something like inspection resource pool or something like that. Once I've set up that resource, I then want to turn it into a pooled resource. To do that, I select the resource object, and I want to click on the additional tab. When I click on the additional tab, I can click in the top left-hand corner here on this pool resource option. When I do that, Simulate is asking me which resources I want to add to the pool, so I'm going to select my assemblers and click this little arrow to move them across, and then do the same for painters. When I'm setting up a resource pool, you can see in this lower right-hand corner, I can specify the priority settings of the pool. If we have the list sequence selected, essentially what will happen is Simulate will look for whichever resource is at the top of the list, currently assemblers, but I can change that using my little hand icons. If there's no assembler available, it will look for a painter, and it will keep moving down the list until it finds a resource. If no resources are available, the work will wait in the queue before or until a resource becomes available. The circulate option will try and alternate between the two resources, and the longest available is particularly useful, for example, in contact centers. This will basically look for the resource which has been idle for the longest amount of time. So I'm going to use that as my option in this simulation. Within pooled resources, we can also set up some proficiency settings. So for example, if our assemblers are maybe less proficient at the inspection station, they may take longer to perform the activity. If I want to set that up, I can select the assemblers, and I can click on this Depends on Resource tick box. Let's say that the assemblers take twice as long to perform the inspection. I can input a fixed value of 2 there, and then tick this little box here to say that they will take twice as long to perform the activity. In my example, I'm just going to return this to the default values of a fixed value of 1. So whatever the activity processing time is will be the amount of time that the assembler is used for. So I can click on OK. You can see when we click, or when we create our pooled resource, you can see that the number available above the resource disappears. And that's because it's made up of the individual resources which make up that pool. So when I click on my assemblers, you can see that it's assigned both to the pool and to the activities which we'd assigned it to previously. I now need to tell Simulate which activities the pooled resource is going to be assigned to, and I just do that in the same way as a normal resource. So again, holding down my Shift key, I can select the pooled resource, I get the little question mark, and I can assign that resource to inspection 1, and then I can assign the pooled resource to inspection 2. I'm going to click on my Home tab now, and I'm going to slow my simulation down a little bit so that we can see the resource animation. I want to reset my model before any run, and this time I'm going to use my Step button. If I click on my Step button, you can see that a work item arrives at bodywork, and we pull in an assembler. If I step again, you can see that we have a piece of work which has arrived and is sitting in this queue waiting to be processed. At the moment, we have an assembler available to work on this piece of work, so really we would want to pull in that piece of work into the activity. The reason we're not pulling in the piece of work to the bodywork activity is because we can only by default pull in one piece of work into an activity at any one time. If we were to run the simulation like this, we would never see any difference between having 2 assemblers or 2 million assemblers, because the system is currently constrained by the number of work items which we can let into each activity. So what we need to do is we need to be able to allow more work into each activity. To do that, I select the activity itself, and then I click on the Additional tab. I then want to change this replicate value here. So I can change this to, for example, 999. And that means that I can let 999 pieces of work into that activity. But if I only have 2 assemblers, I will only ever, at most, pull 2 pieces of work into the activity. So I'm going to change the replicate value for each of the activities that I have an assembler assigned. So because Simulate remembers which tab I was working on previously, this is quite a quick process. So I've changed the replicate value at all of my different activities. Let's have a look at our results. So I'm going to reset my simulation. Because I'm only interested in the results of the simulation, I'm going to turn its speed all the way up. I'm going to run my simulation, and you can see that we have a fairly substantial bottleneck formed before the bodywork activity. If I click on assemblers, which are the resources assigned to bodywork, I want to start trying to investigate why that bottleneck has formed. If I click on assemblers and click on my properties tab, I can actually view the individual results for this resource. And you can see at the moment that this resource is 100% utilized. Whenever we have a resource which is 100% utilized, that's a clear indication of a bottleneck within the system. This is obviously an unrealistically high amount of utilization, particularly because these are human beings, and no human being can be 100% utilized for so long. So when we're now at the stage of experimenting with our model, and I maybe want to experiment with adding another assembler into the pool of assemblers. If I click on assemblers, I can change the number available to 3. When I reset my model and run, this time you can see that we have cleared the bottleneck or reduced the bottleneck significantly, and we've also massively increased our throughput. So in our previous example, if I just change this back to 2, we can see that we're only actually producing 62 blue cars, 29 green cars, and 34 orange cars. If I add that third assembler, just by selecting the resource and changing this to 3, when I reset and run the simulation, you can see that we're massively increasing our throughput. So we've increased from around 60 cars up to 99 blue cars, 29 up to 42 green cars, and 34 up to 41 orange cars. So just by adding that single resource, we've really improved our throughput. We might want to use this simulation as a justification for asking for another resource in our real-life plant. It's given us statistical justification for us investing in that additional resource, because presumably all those extra cars that we're producing over the 2-week period would be more than enough to pay for the assembler's salary. The beauty of Simulate is, though, we can conduct lots of different experiments. So potentially we might look at retraining our painters to be able to work on bodywork, assembly, and assembly 2. That would mean that we've got far less capital to invest rather than hiring a new assembler. The way that we would do that is we would just assign the pooled resource to the activities rather than the individual resources. But I'll leave you to experiment with that in your own time. I'm going to jump back into the slides, and we're going to take a look at a new feature, and that is creating internal spreadsheets. So when we talk about internal spreadsheets within Simulate, we're talking about a place to store information. Simulate spreadsheets don't have all of the functionality of Excel. So for example, we don't input any formulae or anything like that. Excel does its job perfectly well, so if we need to perform any complex calculations, we can use Excel to perform those calculations and then import them into the spreadsheet, or import the results into the internal spreadsheet. As I mentioned as well, spreadsheets allow us to build simple user interfaces. It gives the user a really easy platform to input data in a familiar environment, and then that data can be used within the simulation to drive lots of different parameters, such as the number of resources. It can drive the timing activities. We can even get to the stage where we can have spreadsheets which Simulate will read from to build self-building simulations. What we're going to take a look at is setting the timing at an activity depending on the color of the car which is passing through the activity. So I'm going to return to our simulation. So we're going to take a look at adding timing based on the color of the car at the shipping activity. The reason we might want to do that at the shipping is because we may have different suppliers for each of the different colors of cars, which means they may all have different types or different timings associated with the shipping activity. So if I select the shipping activity, you can see at the moment we have a fixed time or a numerical value of 25 minutes in the timing section here. What we want to do is set up a spreadsheet, and we want to be able to reference that spreadsheet so that we can read a different timing at the shipping activity depending on the color of the car. So first of all, we need to create a spreadsheet. So I'm going to click on my Data and Rules tab, and from the information store here, I'm able to create different types of places to store information. We want to create a spreadsheet, so So I'm going to go ahead and select my spreadsheet there. And I need to give my spreadsheet a name. So I'm going to prefix its name with SS. And because it's going to store the timing information for this simulation, I'm going to call it SS Timings. And I'm going to click on OK. So once I create a spreadsheet, I'm able to click on this little drop-down button below my spreadsheets button, and I can select SS Timings. As you can see, SS Timings looks vaguely similar to Microsoft Excel. However, we don't have all of the functionality within the Microsoft ribbon. As I mentioned, we don't have any formulae within our internal spreadsheets. We just use them for storing information. So I'm going to manually set up my spreadsheet. So because blue cars are represented by a value of 1 within our simulation, I want to store them on the first row. So I'm just going to go ahead and type blue cars. On the second, or on a value of 2 represents a green car. So I'm just going to call it green cars. And a value of 3 represents an orange car. We then want to input some timings into this spreadsheet, and we're going to use the values 10, 20, and 30. Really, it doesn't matter what the values are. This is purely for example purposes. Equally, Simulate doesn't really care what we have in this column here. This is purely for our reference. So we've manually set up our internal spreadsheet, and we can click on OK. When we click on OK, that information gets stored in the spreadsheet. Again, that spreadsheet is just floating around in the background. We need to tell the simulation how we're actually going to use that information. I want to click on the shipping activity, and at the moment you can see that the shipping activity has a timing of 25 minutes distribution. I want to change that timing so that we can look at the color of the car, and then we can have a different average value here. So whenever I'm doing anything kind of fancy like this, I want to click on these 3 little dots. These 3 little dots open up what's called the formula editor, and that basically allows us to input more complex expressions and formulae into our simulation. We could, for example, calculate the timing using a mathematical function, in which case we would build up our expression using the variety of formulae here. I know that my information is stored in a spreadsheets option. When I select the spreadsheets option, you can see that I have my SS Timings spreadsheet available. I can double click on SS Timings, and when I do that, you can see that it populates the formula bar here. Selecting the spreadsheet name, you can see that we have some square brackets, and within those square brackets we have a C and an R. The C stands for column, the R stands for row, and this is basically where I can specify the cell reference of my spreadsheet. I know that so as well as populating those square brackets, it also populates a little snapshot of the spreadsheet. And I can see that my information is stored in column 2 here. So I can input a 2 over my C. When it comes to the row, if I was just to input a 1 here, that means that every single work item would reference column 2, row 1, which would give us a 10. I might want to set that up in certain simulations where, for example, I have all of my different activity names. I can then point those individual activities to individual cells, giving me a single place to update each of the activity timings which I could then import from Excel, rather than clicking through each individual activity. But in this example, what I want to do is I want to look at the value of the label, or of the color label. And depending on the color, that's going to define the row that I look at. So for example, if the car which got pulled into shipping was a blue car, that would have a value 1, and I would look at the first row and the second column, which would be this cell here. If the car was orange, it would have a color value of 3, so I would want to look at the third row. So I know that my row value is going to change depending on what the label is, or the value of the label is. So I know that my information is stored in a label, so I can select my labels option. I know that the value is stored in LBL color, so I can select LBL color. When I double click on the label name, that populates in the formula editor. When I click on OK there, you can see that the timing section has been updated. So we no longer see just a number, we've got this little spreadsheet reference. What this is telling Simulate is whenever a work item arrives in shipping, we're going to look at the SS timings spreadsheet. We're going to look at the second column, and then we're going to look at the value contained within LBL color. If that value is a 1, we're going to look at the first row. So in this example, we only have 3 different timings at the shipping activity, but equally we could have 3,000 different timings, or 1 million different timings if we were processing 1 million different part types. By setting up our simulation in this way, it's a very powerful structure, and it means, for example, that we don't have to have 1 million different shipping activities, each with their own individual timings. We can simply set up that spreadsheet, and we can reference the appropriate row using the label value. So this is something we use very often within our simulation building as consultants, and it is a very powerful piece of kit. At the moment, we have discussed setting up the internal spreadsheet manually, but what we might want to do is have a link to Excel. As I mentioned, by linking to Excel, we can set up user interfaces that allow users to input the data themselves in a familiar environment, and it means they don't have to have any knowledge of how the simulation runs or how to run Simulate. They can just update the parameters, and the model will automatically import them and output the results. So in order to set up a link to Excel, we want to use a feature which is called Excel Connections. Excel Connections, as I mentioned, are a way of allowing us to easily link to Excel, and we can have multiple Excel connections within the simulation. We can either import them individually, or we can import them all at the same time. If I jump back into Simulate, we set up our internal spreadsheet. We now want to set up our external spreadsheet. So I'm going to move into Excel now. I've already saved this spreadsheet. The only reason I saved the spreadsheet in advance was to protect any client information which might accidentally crop up as I was saving my spreadsheet to my desktop. So I've saved this blank spreadsheet to my desktop, and it's called Timing Sheet. I want to replicate the format of my internal spreadsheet, so I'm just going to update the information within my Excel sheet, and I'm going to say we've got blue cars, we've got green cars, and we've got orange cars. At the moment, in my SS timings sheet on my internal spreadsheet, I've got timings of 10, 20, and 30. If I jump back into Excel, I'm just going to set up my timings with something different so that we can be sure that the import has worked. So I'm going to go for 20 minutes, 30 minutes, and 40 minutes. Once I've updated my values, I save my spreadsheet, and then I want to return to simulate. If I click on the Data and Rules tab, I can then, all the way along at the right-hand side, I can click on this Excel Connections feature. If I click on the lower portion of the button for the moment, you can see that we open up our import and export option. We can either import all Excel connections. If I hover over that, we could select individual connections. At the moment, as you can see, there are no connections set up and there are no export connections set up. So what we want to do is we want to click on the top portion of the Excel Connections button. When I click on the Excel Connections button, we are asked, or we're shown a list of the existing connections. At the moment, obviously that link is blank, or that list is blank, because we've not created any connections. So I want to create a new Excel connection. I can give my Excel connection a name in this portion here. This is particularly useful if we have multiple Excel connections set up. I'm just going to leave this set up as Excel connection 1. I then need to tell Simulate where my Excel file is stored. So I'm going to click on my Browse button here, and as I mentioned, my spreadsheet is stored on my desktop, and I can see my Excel file here. If I double click that, Simulate lists the file path. Once we've selected our Excel spreadsheet, Simulate will automatically look through that spreadsheet at all of the different sheets. In my example, we only have a single sheet, which is called Sheet 1, so that is where my information is stored. I can select the relevant sheet from my spreadsheet that I'm going to import on this specific Excel connection. We then need to tell Simulate which of our internal spreadsheets we're going to store this information in. If I click on my drop-down, we only have a single spreadsheet in this simulation, but I personally have built models with between 10 and 50 Excel sheets which have been imported. You can really import a whole host of different information using this method. I'm going to select SS Timings here because that's the internal spreadsheet that I'm using to store the timing information. I then specify the direction in which that data is going to flow. So in this case, we're importing the information, but equally, we might want to export to Excel if we perhaps created some custom or bespoke results, which we'll be covering how to do in the next webinar. The final section here is whether we want to clear the internal spreadsheet or not. If we had varying ranges of data, we would want to clear the internal spreadsheet so that if our first import had 10 lines and our second import only had 2 lines, it would mean that we would only see those 2 lines by clearing the internal spreadsheet. If we didn't clear the internal spreadsheet, we would have 8 extra lines of information. So at the moment, I know that my data range is going to be fixed, so there's no need for me to clear my internal spreadsheet. I'm going to click on OK now, and you can see that that Excel connection has been created. So I can click on OK again. So at the moment, if I open up my SS Timings spreadsheet, you can see that the values remain the same, and that's because we haven't actually executed that Excel connection. So the Excel connection has been made, and we're linked to Excel. We've just not told Simulate that we need to import the information. In order to trigger that import, I click on the lower portion of my Excel connections. And this time, when I hover over Import All, you can see that I could select the individual import, or I could import all. In this example, because we only have a single import, it doesn't matter which option I choose. When I click on the option, you can see that we get a little message popping up telling us that the Excel is being imported. If I look at my spreadsheet now, you can see that those values have been updated. If I click on OK, let's change our values again. Let's say to 2, 4, and 6. If I save my spreadsheet, I can then open up my Simulate again, and I want to run my Excel connection. I'm going to import. When I import, you can see that my internal spreadsheet has the values 2, 4, and 6. So this is really the foundation of how we start to build complex user interfaces, how we can link to Excel to pull in huge amounts of data within our simulations very easily, just by clicking a few buttons with our Excel connections. And as I mentioned, we can also use spreadsheets as a place to store things like custom results, which we can then export into Excel to perform further analysis or use some of the charting features within Excel. So in terms of the features for this webinar, we're at the end of those features. So I'm going to open up the floor to our listeners, and they can ask us any questions, and we'll do our best to answer them in the time that we have available.
Thanks, Max. I'm sure that everyone found it really useful to see how you can use Simulate and link it with Excel, and you utilize the internal spreadsheet. We have got a lot of great questions here from our webinar attendees. So the first question is, can I have shift patterns in my simulation?
Yeah, good question. So at the moment, we've basically assumed that these resources are working for the entire time that our simulation is running, which, as a reminder, if I click on my clock properties, you can see that we're running a 12-hour day, so the duration of our day is 12 hours, and the start time is 6 a.m. That could potentially be quite a substantial shift, so we maybe want to break down the day into individual shift patterns. To do that within Simulate, we want to click on our Data and Rules tab, and below the Data and Rules tab, you can see that we have shift patterns. If I click on the top portion of the shift button, you can see that I can create a new shift. If I click on New, I can give that shift a name. So let's say it's the morning shift. I then need to tell Simulate what the start time of that shift is. So let's say 6 a.m. And let's say that that shift ends at midday. So in this case, I'm inputting the end time rather than the duration of the shift. If I wanted to, I could specify only certain days that that shift was available. So if the shift only worked on a Monday, Wednesday, and Friday, I would use the checkboxes here to define that. I'm going to assume that the shift pattern runs every day. So I'm going to select my everyday option. If we've got a morning shift, it makes sense for us to have an afternoon shift. So I'm going to create that just now as well. I'm going to click on New, and I'm going to call this the afternoon shift. Simulate has already guessed that the start time for this shift is going to be midday. I'm going to make the end time 1800 hours, which is 6 o'clock in our evening. And I'm going to click on OK. Now, a really useful feature within Simulate, particularly if we have several shifts within the simulation, is this Gantt view. If I click on the Gantt view, we can view all of the different shifts within our simulation, and we can identify when those shifts start and when those shifts end. so we can identify any maybe unintended areas of overlap. You can see as well we have these grey areas. Now these grey areas are where the simulation is shut, or the factory is shut. So if we assign any shifts incorrectly, and perhaps assign a shift which is running whilst the factory is closed, that resources utilization is going to be massively reduced, because they're going to be there for work, but because the factory isn't running, they're basically just sitting around doing nothing. So by using the Gantt view, we can make sure that our shift pattern ties up with our opening hours. I can click on OK there and OK again. So at the moment, our shifts, again, are just floating around in the background of our simulation. We've not actually used the shift or told Simulate how we want to use those shifts. If I select my assemblers, for example, you can see that below the number available, you can see that we can specify whether or not this resource is shift dependent. So it's worthwhile pointing out that your resource is either shift dependent or you specify a number available. One will overwrite the other. So if I make the assemblers shift dependent, I might want to say that we have 3 available in the morning. So I select my morning shift and I input 3. On the afternoon shift, I might want to have 2 assemblers. If I click on OK, you can see that the number available has been grayed out. So we no longer care about that as an input parameter. Simulate knows that this is a shift-dependent resource, in which case it's going to look at the shift patterns which we've set up. In the morning, it's going to have 3 available. In the afternoon, it's going to have 2 available. If I reset my simulation, you can see that we have 3 assemblers available. I could set up that for painters, but I think we've seen hopefully enough to answer the question there.
Another question we have here is, can we require multiple resources to an activity? So for example, if an activity needs more than 2 resources to process work. Okay,
so there's a couple of different ways that we can assign multiple resources to an activity. If, for example, we needed both an assembler and a painter at bodywork, I could simply assign the painters directly to that bodywork activity, in which case when a work item arrived at that activity, we would pull in both an assembler and a painter. So that can be relevant for circumstances where we maybe have a forklift as a resource within our simulation. We need a forklift driver in order to be able to perform that task. So we can only perform that task if both of those resources are available. So that's one example of how we can require kind of multiple resources. If we have the situation where we need, let's say, 2 assemblers to perform a bodywork activity, what we can do is we can select bodywork activity and we can click on this resources button. We know we're going to be changing something about the resources, so I can select my resources button. If I click on the resources button, you can see that we have a whole host of different options here. For example, we can set up the simulation to select resources by label, all kinds of fun stuff that we can do with resources. The part that we're interested in is when we click on the Detail tab. When we click on the Detail tab, that opens up this new for us. And this is basically where we can specify the number of resources we require. By default, the minimum number required is 1, and the maximum number required is also 1. So that means whenever a piece of work is there, we will only ever pull in 1 resource. However, if we needed, let's say, 2 people to be able to perform this activity, we could change the minimum number required to 2 and the maximum number required to 2. That means for every individual work item that arrives at the bodywork activity, we need to pull in 2 assemblers. We can also, just whilst I'm on this feature, we can also set up the simulation so that if we have more than one resource available, we might be able to perform a task in less time. So for example, if we were unpacking a box, we can unpack the box with a single resource. So the minimum number required is 1. If we have a second resource available to perform that unpacking, it's reasonable to assume that that unpacking process would take half the time. So we can set up the maximum available to be 2. That means that whenever a work item arrives in that unpacking activity, if we have 1 resource available, we can perform the task. However, if we have 2 available, we will pull in that second resource and the processing time will be halved. Hopefully that answers your. I'm just going to return this to the default values of 1 and 1 for just
now. Another question is, can I keep hold of a resource through multiple activities? For example, say I wanted the member of staff to follow the call going through every stage. Can I do that in Simulate?
You can, indeed. So what we would do for that is, first of all, we need to tell Simulate where we want to take hold of that resource. So what I'll maybe do is just build a separate little example here, and I'll just build it quickly with the paddle. So I'm going to add a little resource here, and we're going to say that we've got 1 of these resources available. It doesn't really at this stage matter what the resource is or what these activities are. For example, though, it could be that we were modeling a hospital and the resource is maybe a bed. When the patient arrives in hospital, they need a bed. They then pass through lots of different activities, and it's only after they've passed through all the activities will they release that bed. What I need to do is I need to assign my resource to activity 9, and that's where we're going to pull in that resource. If I click on activity 9, I want to change an option relating to my resources, so I'm going to click on my resources button. Again, I want to click on my detail tab, and then the area that I'm interested in this time is this middle section here. By default, our behavior is normal, so we will require and release the resource here. So we'll pull in the resource whenever a work item is there. Once that work item has been processed, the resource will return to its base, or it will process another work item. We want to change that behavior so that the resource remains with that work item. So I want to select this second option. The second option is require the resource here, but do not release the resource. So I'm going to click on OK and OK again. We've now told Simulate that we want to keep hold of this resource. We need to tell Simulate when to release that resource. So let's say that we want to release the resource at activity 11. I select activity 11. Again, I want to change an option relating to my resources. First of all, I need to assign the resource to the activity. So I can hold down my Shift key, click on my resource and assign the resource. I can then select activity 11, click on my resources option. Again, I want to click on detail, and you can see that the third option down here is only release the resource here. If I select that option, that tells Simulate where we want to release the resource in order to make it available for any other work items. I can click on OK, and just as a pointer here, if we have changed any of the default settings using the detail button, you can see that we get a little asterisk next to the resource name, and that tells us that we have a non-default option selected. When I click on OK, if I reset my simulation, I'm just going to step through the model. I'll slow the animation down a little so that we can start to see what's going on. so bear with me 2 seconds. Turn to my speed bar down, I'll just reset, and I'm going to step. You can see that the work items arrived in activity 9, and we pull in the resource. If I step again, you can see that we have work building up in the queue before activity 9. The work remains in activity 9 because there's not, let's say in this example, a bed available, and the work item has moved on to activity 10. Attached to that is still the resource. As I continue to step, it's only once the work item is completed at activity 11. So don't worry about all the stuff happening in our car manufacturing example. Once the work item leaves activity 11, you can see that that resource then moves back to activity 9. So in this example, we only had one activity between the two different points. We could have 100 or 1,000 activities between those points. All we need to do is tell Simulate how to, or when to require the resource, and then when to let that resource go. Hopefully that's answered the question.
That's all we have time for now. We had lots of great questions, so if we didn't have time to answer yours, we will be in touch soon. If you missed the first 2 webinars of the series, you can catch up by clicking the link that's now in the chat panel, and you will receive an email when today's webinar recording is available. Thanks again to everyone for attending today's webinar. The final webinar in the series will take place on Tuesday, October the 25th, where Max will take the simulation further and show how you can create custom reports and dialogues using visual logic. See you then.
Thank you very much, everyone.